Summary of Structure Construction Drawing. Hello everyone. Welcome to the class of Architectural Drawing and Reading. In the following, we will study Chapter 10 Structural Construction Drawings. The content of this chapter is divided into 3 sections. Overview of Structural Construction Drawings, Foundation Construction Drawings, and Floor Structural Layout Drawings. First, let's explain the overview of structural construction drawings. In structural construction drawings, 1. Structures and components. Structural design is based on the various requirements of the building, selecting structural types, and arranging structural components. After structural calculations, determining the shapes, dimensions, materials, internal structures, and construction requirements of the building's load-bearing components. The result of structural design, drawn into drawings, is the Structural Construction Drawings, abbreviated as CD. Structural construction drawings are the basis for construction, setting out, trench excavation, component fabrication and installation, and guiding construction. They include structural design specifications, structural plan drawings, and detailed drawings of various load-bearing components, beams, slabs, walls, columns, and foundations. Generally, common building structures and components: columns, main beams, secondary beams, slabs, walls, foundations. 2. Contents of structural construction drawings. 1. Structural design instructions, including soil conditions of the foundation, types, specifications, and strength grades of the materials for selected structural components, selected standard drawing collections, construction requirements, and precautions, etc. 2. Structural plan drawings, including 1. Foundation plan drawings. For industrial buildings, there are also equipment layout plans. 2. Floor structural plan drawings. For industrial buildings, it also includes column grids, crane beams, intercolumn bracing, tie beam layout, etc. 3. Roof structural layout plan drawings. For industrial buildings, it also includes roof slabs, gutter slabs, roof trusses, skylight trusses, and roof bracing system layout, etc. 3. Component detail drawings. 1. Section detail drawings of beams, slabs, columns, and foundations. The foundation section detail drawings should be arranged on the same drawing as the foundation plan as much as possible, so as to be convenient for construction with reference. 2. Stair structure detail drawings. 3. Roof structure detail drawings. 4. Other detail drawings, such as gutters, canopies, etc. 5. Commonly used component codes. In structural construction drawings, the positions of structural components are represented by their schematic codes. These codes are represented by the first capital letter of the Chinese pinyin, the standard for architectural structure drawing, GB or T 50105 to 2010, specifies the codes for structural components, as shown in the following table. The slab is represented by a capital B. The roof slab is represented by WB. The ring beam is represented by QL. The stair slab is represented by TB. The beam is represented by L. The balcony is represented by YT. 4 Scale of structural construction drawings. For structural plan drawings and foundation plan drawings, the commonly used scales are 1 to 50, 1 to 100, 1 to 150, 1 to 200, and the available scale is 1 to 60. 5. Basic knowledge of reinforced concrete structures. Reinforced concrete is composed of concrete and steel bars. The concrete is on the upper part of the component and bears the compressive force. The steel bars are located at the lower part of the component and bear the tensile force. 6th, the production process of reinforced concrete members is divided into blanking, steel bar processing, steel bar installation, pouring and curing. Blanking. First, cut the steel bars with different diameters, according to the required lengths. Steel bar processing. According to the design requirements, carry out bending and forming. Steel bar installation. Bind or weld the bent, formed steel bars together to form a steel bar skeleton. Pouring. Place the steel bars inside the formwork and pour concrete, a mixture of cement, sand, gravel, water, and various additives. Curing. After the concrete has solidified, remove the formwork and it is completed. Reinforced concrete members are divided into cast-in-place members, prefabricated members, and pre-stressed reinforcement. Concrete members build formwork on the project site and pour in place. Prefabricated members be prefabricated in a factory outside the project site and then transported to the site for installation. Pre-stressed reinforced concrete members during the manufacturing process. By tensioning the steel bars, a certain amount of pressure is pre-applied to the concrete in order to improve the strength and crack resistance performance of the members. 7. Classification of steel bars. Secondly, role of steel bars. Steel bars in concrete are not placed as single, isolated units, but rather individual steel bars are tied together with wire or welded into steel bar frames or meshes, as shown in the figure. The main load-bearing steel bars are those that bear the internal forces of the component. Erection steel bars serve a supporting role to form the steel bar frame. Stirrups fix the position of each steel bar and bear the shear force. Distribution bars used in slab-type structures distribute the force borne by the slab surface to the load-bearing bars and prevent the concrete from cracking, while also playing the role of fixing the position of the load-bearing bars. Other steel bars, such as lifting rings for hoisting and embedded parts, set for structural requirements. Third, hooks on steel bars to enhance the bonding force between the steel bars and the concrete. The ends of plain round bars are to be bent into hooks, as shown in the figure. Fourth, steel bars symbols. Please practice the expression of reinforcing bar symbols, and understand the significance of reinforcing bar illustrations for the ends of steel bars without hooks. The figure below represents the length when short steel bars overlap in projection. The ends of the short steel bars are indicated by a 45-degree diagonal line when configuring steel bars. In structural slabs, for double-layer steel bars, as shown in the figure, the hooks of the bottom layer steel bars should face up or to the left, while the hooks of the top layer steel bars should face down or to the right, as shown in the figure. If the stirrups, hoop bars, etc., shown in the figure, are complex in layout, detailed drawings of the bars and explanations can be added. Instructions for drawing reinforced concrete component drawings. Steel bars are not drawn according to the actual projection, but are represented by single lines only. To highlight steel bars in the reinforcement drawing, the visible steel bars should be drawn with thick solid lines. The cross-sections of steel bars are represented by black filled dots. The invisible steel bars are drawn with thick dashed lines, and the pre-stressed steel bars are drawn with thick double-dotted lines. The outline of the component is represented by thin solid lines. In the cross-section, the material symbols are not drawn. The thick solid lines for drawing the steel bars and the black filled dots representing the cross-sections of the steel bars have no changes in line width and size. That is, they do not represent the size of the diameter of the steel bars. Fifth, steel bars cover to protect the reinforcing bars from corrosion. The steel bars cannot be exposed outside the component, and a certain thickness of concrete must be used as the protective layer. The protective layer also serves the purpose of fire resistance and increases the concrete's grip on the steel bars. The size of the protective layer can be found in the table below. The minimum thickness of the protective layer for reinforced concrete is associated with environmental conditions, component categories, and concrete strength grades. 8. Examples of reinforced concrete components. Reinforced concrete beams are composed of load-bearing bars, supporting bars, and stirrups, while reinforced concrete slabs are composed of load-bearing bars, structural bars, and distribution bars. Ninth, content of reinforced concrete component drawings. 1. Formwork drawing, that is, the outline drawing of the component. For components with simple shapes, it is not necessary to draw a separate formwork drawing. 2. Reinforcement drawing mainly expresses the distribution of steel bars within the component, usually including reinforcement plan views, reinforcement elevation views, reinforcement sectional views, etc. 10. Illustration methods. For reinforced concrete components, all kinds of steel bars within the component should be numbered for easy identification. The numbering is in Arabic numerals, written in a thin solid line circle with a diameter of 6 mm. It is also necessary to mark the type of steel bars the diameter, and the number of bars, or the spacing in this component. Dimension marking on steel bars drawings. The form of dimension. Writing on steel bars drawings has obvious characteristics compared with other engineering drawings, as shown in the figure. For the overall dimensions of the component, the positioning dimensions of the component axes, the positioning dimensions of the steel bars, etc. They are marked in the ordinary way. The quantity, varieties, diameter of the steel bars, as well as the evenly distributed spacing between the reinforcing bars, etc., are usually grouped together with the steel bar numbers and marked with leader lines. The segmented length of the formed steel bar is directly written beside the steel bar without drawing dimension lines. The bent-up angle of the steel bar is often noted in the form of components, and the component lengths in the horizontal and vertical directions are noted. For the convenience of material statistics, a steel bar table is often drawn on the traditional steel bar drawings. Please take a look at the table below. This concludes the content of this section. Thank you for watching.